Hello, this is the second part of a series of 4 videos where I explain a technique of integration called trigonometric substitution. Now, in the first part, we dealt with integrals containing square root of x squared plus a certain number. Here we are going to deal with integrals containing square root of a number, which is 9 here, minus x squared. So the integral that we will be solving is integral of square root 9 minus x squared over x squared dx. The substitution that we do here is that we let x be 3 sine theta. Surely we are using 3 because 9 is 3 squared in order to get rid of the square root in when we substitute x by 3 sine theta. Now theta is going to be between minus pi by 2 and pi by 2. Now, as I said in the first part, theta can be in R because the domain of definition of sine is R, but on the interval minus pi by 2, sine is strictly increasing and it has an inverse. But again, I'm not going to go into details because it's not the goal of this video. So theta would be between minus pi by 2 and pi by 2. So x is 3 sine theta, which means dx would be 3 cosine theta d theta because the derivative of sine is cosine. And square root of 9 minus x squared would be square root of 9 minus 9 sine squared. We take 9 into factor, we put it outside the square root, it's going to be 3. So it's 3 square root of 1 minus sine squared. 1 minus sine squared is cosine squared. Square root of cosine squared would be absolute value of cosine. And since theta is between minus pi by 2, cosine is positive in this interval, which means the absolute value of cosine would be cosine. So the square root of 9 minus x squared is now 3 cosine theta. So my integral would become, I'm going to replace square root of 9 minus x squared by 3 cosine, x squared or x, I'm going to replace it by 3 sine, and dx would be replaced by 3 cosine theta d theta. So our integral becomes integral of 3 cosine theta over 3 sine theta squared multiplied by 3 cosine theta. So here 3 and 3 by 3 over 3 squared, they will cancel. We get cosine squared over sine squared, which is going to be, I'm sorry. So cosine squared over sine squared, it's going to be cotangent squared. To integrate cotangent squared, we use the fact that cosecant squared theta minus cotangent squared theta is equal to 1, which means that cotangent squared is cosecant squared theta minus 1. And the integral of cosecant squared is minus cotangent. And the integral of 1 is theta. So my integral I becomes equal to minus cotangent theta minus theta plus a constant c. Details about cosecant and cotangent, you can find them in a video where I speak about cosecant, secant, and cotangent and tangent. Now we have to go back to our initial variable, which is x. Always when you make a substitution, you have to go back to your initial variable. So we look at the substitution that we have done, and we look at the square root. So the substitution that we've done is x equals 3 sine theta, which means sine theta would be x over 3. And also square root of 9 minus x squared, it's 3 cosine theta. So cosine theta would be the square root of 9 minus x squared over 3. and we have cotangent. So cotangent is cosine over sine. So let's see what we will have. So cotangent theta, it's cosine over sine theta, here minus theta plus c. So as we have just seen, cosine, it's the square root of 9 minus x squared over 3, and sine is x over 3, and then we can simplify by 3 if we like. Now, theta, we can write it as sine inverse of x over 3, and we can write it as cosine inverse of radical 9 minus x squared over 3. But since the substitution that we have done was x equals 3 sine theta, it's preferable to write theta as sine inverse of x over 3, surely plus a constant c, because we were solving an indefinite integral. Thank you for watching.